you can see. So this is a feedback control system. As we know that feedback control system is also called as closed loop control system. So it is called as closed loop. So the loop is closed. That means we always have a feedback system in place. So that is what is feedback control system. So you can see here, see this diagram. Here it is a control system. So mainly the variable here is S is called as the Laplace variable. So it is a Laplace variable. Generally, control system mostly it happens with Laplace transformation. So that's why they use a value rather than t. They use S. Okay. So S is for this Laplace. The systems generally they represent with S, and time to system they represent t. Okay. So we have t here and we have S here. Okay. Now you can see there are four components here. So the component one is controller, next component is actuator, next is plant, and next is sensor. If you take any cyber physical system, these four components will be of prevalence. So they are prevalent. These four components are prevalent in any cyber physical system. So it should have a controller, it should have a actuator, it should have a sensor, and there should be a plant. So here, as per this action, the sensor is in the feedback, because the sensor keep on aggregating the data and then giving back and forth between the output and the input. So that's what the job of the sensor. So the sensors can able to talk between the output as well as the input. Okay. So additionally, we have some disturbances also from the output here. So actually, this is a feedback. Okay. So this line is the feedback. So from here it is feedback, and we have n of t. So this n of t will be the disturbance, additional disturbance sent to the sensor. So that's why we have a value yn of t. Once it is goes inside, when it comes outside, it is ym of t. So the yn of t will become ym of t, and once it comes yd of t, and here this is ym of t. So when both these things goes inside, there will be em of t. It will be em of t. So that is the closed loop control system. So that means, so one good example is just say if your faculty is not good enough, so his teaching skills is not good enough. So if you suggest a feedback, so this is the feedback. So then the faculty might improve. So that means that feedback comes to the faculty. The faculty see that okay, these mistakes I am doing, so I will not do it. So let me refine it. So that way it is fed back into the system again. So that is what this em of t. In many places we can able to see this closed loop control system, or generally we call feedback control system. But in India, we have plenty of industries, we have plenty of manufacturing industries. Most of those industries still they are open loop system. So there is no feedback control system available on those systems. Still they are open loop control system. So what you do is obviously you will be ending up in some fake products. So the products will be of not so good quality, and they will be just breaking, wear and tear will be there very easily. So they don't do the quality control or quality assurance, they won't provide. So that is what happening with many of the company products, because the quality is not been maintained. So one good example here is the batteries you can see. So here I have a phone. So as I already told you, I usually use one phone. This Android for testing. So some of the things I will be testing it. Okay. And here I never experienced that. Usually, if I have an iPhone and this phone, both are equally good enough. iPhone have the seamless transmission. So when I get a phone call, I'll get a call in my iPad as well. So that, but this phone, I'm having a OnePlus phone. So I travel to a lot of places. So every time I use only this as a mobile camera. So I use this to shoot all the videos because I love the camera, which is more powerful than what an iPhone has. At a cheaper rate, I got it in this one. So almost both the phones crossing almost 3 years and 2 years. So what I do is I expected a quality product. So I don't mind in investing the money so that I will get a quality product. So that's what I just experienced. Everyone have the experience on the same thing. Okay. Now one example here is, let me show you. Anyway, I don't, okay, just see a cable here. So just see a cable here. It's a multi-purpose cable. Okay. So it's a multi-purpose cable. So this is an input. So this USB is the input, and these three cables are the output cable. So output means one is for Apple, another is for USB-C, another is for mini USB. So these are the three outputs. So this cable I purchased around 200 rupees. So 200 rupees. Maybe I know that it's low quality, but anyway, I want to keep it in the campus. So whenever I put a charge on this phone, whether an iPhone or anything, the iPhone even not even it move for 1%. When the full day when you put charge, it will charge 4%. 55 means it will be charged to 60. So that's what the full day when you put charge. Even the USB-C also same thing. So this is not what I expected. But mini USB works fine. Mini USB working fine here. So these two. Even I tested the connectivity also using the connectivity tester also. I could not able to get a good product. But had I used some 1,000 rupees and got a product, it might be surely well enough because of this. So even I provided a feedback also. And even after giving feedback also, you are not going to get a good quality product. So this is what many companies in India they are of this nature. Okay. So now to the controller accepts the input as well as the value from the feedback. So both are being fed back into the system. So the purpose of this feedback is to the error rate to be minimized, E to be minimized. So E means usually we call epsilon or E. So epsilon usually we call it's a error rate. So that error rate has to be minimized. Further only we use the feedback system. So once the error rate approaches zero, so it never happens, but to the very minimal value when this approaches, then you will have always have a perfect system. You will always have a perfect system. So this is how it happens. Okay. So once the controller is there, from the controller, the output is UC of T. There is controller output that is fed back to the actuator. So once outside the actuator, so UA of T. So when it comes out the actuator, then we have a DA of T. Some inputs also there, DA of T. So some data inputs there. So that will be fed back to the plant, and the plant will be operating on it. So this is generally a feedback control system. So let us not bother about the naming gimmicks here. So we have a controller, we have an actuator, we have a sensor, and we have a plant. So this is how the way most of the manufacturing systems it works on this feedback control system. Okay. So mostly most of the industries nowadays they went for industry 4.0. That means the next level of industrial internet of things. So they have migrated, but still now many industries they are in the open control system. So they don't have any feedback to be done now. Sorry, to be happen. Okay. Okay. So next thing is some of the examples. So if you take an example of a feedback control system, so we have something like a this is a toilet flush. So generally we call a toilet flush. Okay. So every one of you have in your home. So it's a Western toilet. So anyway, Indian toilet also nowadays have this option here. So this is one of a perfect feedback control system. That is a closed loop control system. I'll just explain you about that. So we have a valve here. So in the left hand side we have a valve. So that valve will be controlling the water. So there is a floater here. So generally you can see when you open the flush of your washroom, you open this tank there. So water will be pumping. So this valve is adjusted. This valve is controlled by a floater. So once the water is filled to a top level, the floater also will be coming to the top. So once the floater is coming to the top, that it automatically locks the valve. So the valve will be locked. So that water inlet will not be there. So that means once the tank is full, the water inlet will be stopped automatically. So that means water will not come in. Once you flush it, all the water goes via here. Once you flush, all the water goes via there. So once it is done, then again the floater will come to the bottom. Again, what happens once the floater comes to the bottom, the valve gets open. So the valve will be like this. When the floater is there, the valve will be tightly locked. Once it is there, the valve will be opening like this. In that case, automatically the water will be coming inside. So make the floater to come to the top. Okay. So this is how the way the flush tank it operates. Mainly, it operates this way. So this is a perfect. We can see a plant is the complete. The tank is a plant. Okay. The floater is the sensor. The floater is a sensor because it is an indication shown that the valve is a controller. The valve is a controller. So the flush, what you use the actuator. So you are actuating it. So all these four components will be there in this part of this feedback control system. So this is one control system. Hello. Yes. So this is one control system we happen to see every day in our house. So this is a perfect feedback loop control system or closed loop control system. Next one is we go for a single link robot with a DC motor. single link robot with a DC motor. So DC motor, so it is like a, as you can see here, let's say this is arm of a robot. Okay, so this is a plate here. Okay, now arm of a robot is, I am just, the arm will be moving here, picking something and place it somewhere here. Then again it will do this. So it's an arm of a robot is picking and placing this. So it has a load, but it's a robot arm. So this is what here it indicates, this is a DC motor. It's a DC motor. So generally the DC motor we called as a PMMC motor. PMMC means permanent magnet moving coil. So this is a PMMC motor. Usually this is a DC motor where it has a permanent magnet moving coil. So this DC motor. So arm of a robot will have only two things. So either this can pick and place. So there will be some something, the arm will be rotating here like this. Okay. But here in this case, this is a motor. So it will be pick and place. Okay. Now in that case, we have a DC motor and we have a device called as a potentiometer. Potentiometer. So this is a device, potentiometer. So one good example I will do potentiometer. So when you vary the resistance, when you increase the resistance, the speed of the DC motor will be slow. When you decrease the resistance, the speed of the motor will be high. So lower the resistance, speed is high. Higher the resistance, speed is low. Okay. So based on the adjustment of the potentiometer, the plant will be controlled. The entire plant is controlled. Okay. Now one good example here is the fan knob in your home. The fan. You have a ceiling fan. You have a knob to adjust the speed. So 1, 2, 3, 4, 5. Total there will be 5 speeds. You can adjust the knob. Okay. Now earlier days knob will be, you will get a sound, tuck, 4, tuck, 3, 2, like that you will get a sound. Okay. Now we have a knob with no sound, just it's only a smooth rotation. You can see that there will be a knob. Okay. So now the potentiometer is multi-level potentiometer wherein you can have multi speeds, the fan will work. So what we are actually doing is we are supplying, we are reducing the voltage flow by increasing the resistance. So if you go to 1, the resistance is very high. So the supply voltage will be goes to the fan with the less voltage. So the fan will rotate slowly. If 5 means the supply voltage goes to the fan will be very high because the resistance is very less. The same concept here, the arm of a robot. So usually they will be controlling the motor by supplying the resistance value. So this is what another feedback loop control system. So here we have these equations here. So what happens here is V of t, it goes here into the comparator. Then we have this angular velocity. So here the control will be the angular velocity. Angular velocity means, so this angular velocity, how fast it moves. So that is angular velocity of the particular motor. So that's what they said, the arm of a robot. So this in most of the industries they use arm of a robot mainly for assembling things. Okay, so mainly for assembling things you can see these kind of examples. So one good example is maybe usually they never permit us to shoot a video or a picture inside a plant. Okay, now in Ford in Chennai there is a Ford for assembling the cars here actually. So what did they do is the door, the 4 doors of the car will be coming from some manufactured plant, not in India, somewhere from abroad it comes here, and they will assemble it here. In Chennai, they assemble it. That means the arm of a robot will take the door from a particular stand and fit it to the car and screw it, tight it. All these things done by a robot. So they have a very big robot. So like that, the robots will be running like this here and there. It will be moving on like this. So there will be 4 robots aligned in line, and all the 4 robots in a particular given point of time, they will fit one car. It takes 15 minutes, one car. Just think of how many cars the 4 robots can able to do on a particular day. So that is again the feedback control system. So it every time it verifies the precision is good and the accuracy is perfect. So all these things will be verified by the robot themselves. Okay. So this is on this feedback control system. Now next concept here is human in the loop, HITL. So human in the loop. So generally in many places human play a major role. Okay. So human beings play a major role. Human in the loop is a concept that requires human interaction. The modeling and simulation that requires human interaction. So one good example here is while you play the video games. Okay, so video games at times it will be asking for the human input. Only when you supply an input, the game will continue. Else the game will be infinitely waiting. So without touching anything, the game never cross it. So in that case, 1 minute sir. சார் கிளாஸ் எடுத்துட்டு இருக்கேன் சார், முடிச்சுட்டு கூப்பிடவா? இல்ல கிளாஸ் சார், கிளாஸ் 5:35 நான் கூப்பிடுறேன் சார். ஓகே சார். ஓகே. So human beings, sometimes the user has to press a button, sometimes the user has to trigger an event, sometimes the user has to press touch of a phone. All these actions it based on the human interaction. So generally any system designer, when they go for designing a system, they always make the human in the loop. Okay. So two aspects of human in the loop: one is human machine interface, human computer interface. So we have two things: so human machine and human computer interface. If it is a machine, so it accept the humans triggering of event should be happening in the machine. Okay, that is human. Human computer interface is there. So one good example here is we have a centralized air conditioner here in my room, but of course AC is not there because of this pandemic. But whenever if I want to switch on the AC, it is an automated system only. So the air conditioner is completely automated, but it never works in the automated mode. That means the human interaction should be there at least to switch on the AC. Okay, so it will be waiting for some time. If nobody is there around, it automatically switch off the air conditioner. That it will do, but switching on, it won't do that. So we have to go and do. So that means they accept a human in the loop system. Else, what happens? It will be the air conditioner will be keep on running if somebody is not switching it off. So that way they don't want to waste the energy. So that's why they make the human machine interface there. So that is one. Human computer interface, HCI. So human computer interface means in computers, let's say in your games. So when you play the games or when you do some embedded system operations, so at times it will ask for the user input. So that way we call human computer interface. So always the cyber physical system engineers or the embedded engineers, they always have an option called as human also into the loop, the system. Okay. Now you can see there are two things. It is taken from a journal paper. One thing in the physical world, another on the computer system. So there are two aspects of it. Right side is a physical world, left side is a computer system. So computer system is modeling and simulation. So generally in the simulated world. So here we have schedule, as is site conditional model, and human factor model. So generally is modeling and simulation. We have these three aspects of human in the loop. Schedule the events. So that can be done by the human only. Then as is site condition model. So as is site condition model means whatever be the simulated software. So as it is, when it being produced based on some conditions, so that condition also has to be triggered by the human being. Then human factor model. So human factor model again. So in case if you have long ago, I just seen on website called as Second Life. So there is one app called as secondlife.com. So not an app, it's a website. So they give a piece of software to you, so you can download the software to your machine, and then you have a second life. Like it's a social network, kind of a Facebook or something like that. What here happens in Second Life is you can fly. So you have your own naming, your own ethnicity, your own dress materials, and so your own. If you are so dark, you can make so white. If you are so white, you can make yourself brown there. You can fly. In real world, in the first life, you can only walk, you can sit, you can sleep, but there you can fly also. So in second life, you can fly also. Now that is a kind of a human simulation there. So physically, you can earn a degree also in MIT. So MIT also offer a particular course in secondlife.com. So there you can go in the second life and earn a degree on a first life. That also they are doing. Even you can watch a movie in second life. You can go to a theater. Inside the theater, the film will be running. They have a show time also as per their own time zone. So you go to the time zone, you watch the movie there. So in the second life, so such kind of facility they have in second life, but human in the loop there. So you will be part as a graphics. You will be shown as a graphics inside the software, but you will be practically or you are physically working on your computer to present in the particular theater to watch the movie in second life. Okay, so people will be roaming here and there. All are real peoples, but they are being simulated in the human in the loop environment. So maybe if you are not seen this, maybe you can check this. So maybe I have just done 10 years ago. I have just seen this. Anyway, suddenly just came across my mind. Secondlife.com. So in the physical world, you can see we have human, we have workspace, we have task. Okay. Now let's say if you take a nuclear reactor. So nuclear reactor cannot be completely automated. So if you are automating it, it's fine, good. But at times beyond something, so yeah, human presence should always be there. So if let's say the radiation is beyond our control, okay, and some human being has to go and shut down it. So manually they have to go and shut down it. Unless it will be a catastrophic danger if it go for the automated one. I'll just tell you one. 2 years ago, there was something in UK. There is one a fulfillment center. Fulfillment center means the place where all the e-commerce materials will be delivered from the. That's a godown. So it's kind of a very big center where they just dump in all the things. It is completely robotized. The complete industry is robotized. The robots will move here and there, picking and placing it, and they're just putting in the rack and then take it out and all these things. One day there was a fire in the particular center. There was a fire. Okay, but the robots, since they are robots, they can handle fire. So there was some glitch in the robotic system where they do not experience fire. When the fire engine have come and they are just put down trying to seize the fire, but the robots are running here and there inside the factory. They are running here and there, picking and placing. All these things the robots are doing because the robots can experience heat. That was not been programmed for the robots. So the robots are programmed that they can withstand the heat. But even when there was fire, the robots can still withstand their heat, and they were moving here and there. So they had a tough task. It was happening near somewhere near London 2 years ago. So that is a collapse of a complete cyber physical system. So these kind of things, in those situations, human in the loop is always mandatory because human beings can able to arrest the fire at some cost. Okay, so without automating it. So now this you can see a cyber physical system. This is actually the human in the loop diagram given in your book. Okay, so cyber physical system require cyber physical system or cyber physical system have applications in. Okay, so three cycles. First, let me go like this. Cyber physical systems are feedback systems, possibly with human in the loop, economics in the loop, environment in the loop, and human in the loop. So three aspects. So if you see the statement here, so the diagram, the statement what I have given is CPS or feedback systems, possibly with HITL, human in the loop, then EITL, economics in the loop, then environment in the loop, EITL, environment in the loop. So that is the first statement. The second statement is cyber physical systems are feedback system that are networked and distributed, adaptive and predictive, intelligent and real time. So we can see that cyber physical systems are net feedback systems that are adaptive and predictive, networked and distributed, intelligent and real time. Okay. Now that cycle over. Now next cycle is CPS requires cyber security, which is resilient, privacy, malicious attacks, and intrusion detection. So CPS requires this. Then CPS require imported design tools that enable design methodology. CPS requires imported design tools that enable design methodology. Then finally we have applications. So CPS applications in communication, consumer, energy, infrastructure, healthcare, manufacturing, military, robotics, and transportation. So it has all these options. That is what we call as a human in the loop system. So CPS at any point of time without human being, the CPS cannot live. So the cyber physical system, any system, whatever you call automated system or a feedback loop control system, closed loop control system or open system, there should always be the presence of human being should be there. Okay, so of course human beings cannot be replacing a system, but without the human being in a particular, the absence of human being in the particular system will not be a good suggested system. Okay, so that's all on this HITL. So next I will move to the same continuation of this. industrial Internet of Things. So comparison between industrial Internet of Things, M2M and Industry 4.0. Actually, this is in module number 3. So we are in module number 3. So module number 2, there are two more topics left in module number 2. The topic is one is predictive model control system, predictive model based control system. Another is distributed CPS. So distributed CPS. So these two are pending. Actually, we need to complete Ptolemy for understanding this distributed CPS. We need to know about Ptolemy tool. Only then we can able to tell you what is a distributed CPS. So that's why I'm just leaving it now. During the coverage of Ptolemy, I will take this as one of the case study of distributed CPS. So then I'll cover it. That's why I'm just leaving it there, and I'm going for module number 3. So in the module number 3, we have communication aspects, networking aspects, and so many things. Now to begin with, we can see the comparison between these four things: CPS, industrial IoT, M2M, and Industry 4.0. So this we will be seeing. So generally we call IIoT means Industrial Internet of Things. Industrial Internet of Things, Industrial IoT. Next thing is machine to machine, M2M. We generally call machine to machine. And what is the relation between machine to machine and IIoT? Then some use cases. We'll see some use cases of industrial IoT. Okay. Now when you see industrial IoT, actually industrial IoT is equivalently we'll be calling it as CPS, cyber physical system. Okay. So industrial IoT, we can see there are four aspects: industrial, consumer, commercial, and enterprise. So these four aspects. So you can see that industry requirement is very high for this CPS. Next thing is consumer. Next thing is commercial. Then finally we have enterprise. So we have these four aspects. So only industry needs more amount of this IIoT or this CPS, Industry 4.0. So how the industry migrated towards it. So I was telling that the number of industries, manufacturing industries, particularly in country, Tamil Nadu leading with 39,000 plus industries, not IT industries. Leaving out IT industries, Tamil Nadu has 39,000 plus industries in this state. Next thing is somewhere around 30,000 plus in Maharashtra. Next thing is Gujarat, somewhere around 23,000 plus industries in Gujarat. Okay, now among these, when you take these three states, after that the other states come. So when you state these three states, more than 50% of them have been migrated to Industry 4.0. 50%. Remaining 50% are still under the older industrial system. So that means they have not migrated to Industry 4.0. So most of them, most of the aspects of the industry, they do manually. So they do manually. Manually means they don't have any these protocols, communication APIs, how we can have machine to machine communication. These kind of things they do not still have. Yet they are running in the very old mechanism of running the industry. Okay, so that is how the way the industries are doing it. Okay, one company I just went sometime. Swing, not Swing. Their name something Stetter. There's a company. Not Swing. That is something Swing Stetter. That is the name of the company. Okay, it is somewhere in near VIT Chennai, so almost some 20 kilometers away from Chennai. Here from our campus, we have taken our students for a demo there. Not students. We went for a fingerprint demo. Okay, so after we go in, we were waiting at the gate. We were waiting at the gate. Okay, so the employees are coming one by one. Okay, so most of them, there are laborers, there are technicians, and there are officers. Officers, technicians, no issues. But laborers, they have not educated at all. So what do they do is right from the entry, everywhere, whenever they see green color, they can proceed. Whenever they see red color, they have to stop there. Right away, they have to stop. No need of progressing further. They have to stop it. Okay, right away from biometric to enter inside the company, enter inside the plant. They have the lines, the green lines. So only when they see green, they can proceed. Whenever they see any other color, they have to wait. So likewise, they educated the particular labors. So even the people they so don't know how to read and write, but they are machining operators. So for them, they have implemented. So very high-fi system they have done it. So even when, even suppose for example, if any intruder comes to the gate, then when the intruder comes and enter the factory, then it will be alerting the control room that some intruder has come. So there is an alarm there. There's an alarm indicating that he is an intruder because without an identity card and without any scanning, he has entered that. So there is an alarm in the control center. So likewise, we have never experienced a company, the company one who produces the um, uh, the cement machines. What do we call the household machines like bricks, sand, carrying vehicles. They are in part of producing those vehicles.
So concrete mixes.
Yeah, concrete mixes. Yes, correct. Yes, yeah, concrete mixes. Okay, so that kind of things they are just producing there. So we went. So that company was so high-fi. Even we have gone somewhere around 4 5 years ago, and that time itself they were in Industry 4.0. So we want to implement biometric in our campus. So you hope you might have seen the hostel biometric. After we discussing with so many companies, we went. So only the vendor took us there. Sir, we have deployed one biometric system there. You please come and see a demo. So that's why we went for the demo there. So that company, they were in Industry 4.0, just in I'm just 2015. So during that time. Now think of what could be their stage now. So that's how the way they do. And even in the cafeteria, mess, in all the locations, they have similar kind of procedure. So everywhere when an employee enters, they have to have a biometric to enter inside. Else their door won't be opened at all. Okay. So that kind of thing they were having. So industry needs much of this CPS and Industry 4.0. Okay, now through this machine sensors, middleware, software, and backend cloud compute and storage systems, we need all these aspects when we deploy Industry 4.0. So machine sensors already we are doing it. Middleware. So middleware does so many jobs. It provides interfaces between different heterogeneous systems. It provides. Then software. Then we have cloud compute and storage systems. So cloud computing means the how your data will be stored to the cloud for retrieval. So further we need to have the cloud computing as well as the storage systems. Okay. So now you can see M2M versus IIoT. So you can see here, the right hand side is IIoT, the left hand side is M2M. So M2M, you can see we have a car directly interacts with the app. It have a direct connection with the app. Similarly, an aeroplane, it have an app. So there is airport reservation or airplane reservation system. Then we have factories, it has an app. So likewise. But now in industrial IoT or an IoT, we have a web as a platform. So all the data will be stored. The things can store the data to the web, and the app can fetch the data from the web. But here, the earlier days, in the M2M, it is not happening that way. The web component is not there, but maybe directly they can interact with each other. The app can interact directly with the application things directly. But here, the things can interact to the app via the web. So this is what industrial IoT demands. So you need web as one of the layer, but there is some disadvantages also. When you are opening everything to web, there could be chances of attacks. There could be chances of bugs, malwares. All these things happen when you introduce web into the system. When your protocols are not so strong. So in that case, obviously IIoT have a slight disadvantage. But anyway, when compared to the cons, the pros are very high. The advantages are very huge and compared to the disadvantages. So everywhere we have these attacks, everywhere is common, but we have to live in the system where we have to overcome those attacks. Okay, so that by having IDS, IPS, intrusion detection system, intrusion prevention system, something like that we have to have. So the functional domains of IIoT. So what are the functional domains? So ultimate thing is business. So everyone want to do business. That's it. The purpose of main purpose is to have business. Then we have physical system. So without the physical system, we cannot. So internally, we have these things. So we have control and we have operations, information, and application. So these are the four things that they're in the functional domain. So control through sensor and actuators. The sensor senses, actuator actuates something. So that is under control. Then operations. So what are the different operations that you can perform on the plant? Then information available in the plant. Then applications. So what are the different applications? Okay. So that is on functional domains. Then control domain. In the control domain, what are the different things in control domain? So we have operations, Prognostics, optimization, monitoring and diagnostics, provisioning, deployment, and management. And customer A, customer B, customer C, like that. So this is under control domain. So prognostic and diagnostics. So these are again two aspects of it. Prognostics and diagnostics. So diagnostic means if something bad happened to the machine, so somebody come and examine the machine and trying to find out what happened in the particular machine. Prognostic means the machine records the state itself. So the machine knows that what is happening within its own, and then it will be maintaining the history of the particular machine. It's something like a black box. Okay, so that is on the prognostic. So mainly this control domain says that the machine knows itself what is happening. So how long the machine is running, how many times you have switched on the machine, how many times the machine has been shut down, how many times the fault occurs. So all these data will be stored in the machine. So that is what this prognostics thing. So in control domain we have all these things. So provisioning deployment means when the deployment time, so how much time it takes to deploy a machine. Okay, so please remember, if you take boiler for example. So oil producing, say acid producing machines, acid producing. Let's say if you take sulfuric acid, nitric acid, concentrated nitric acid, concentrated sulfuric acid, mostly they have been prepared with the boilers. So boilers means not a thing. So sometimes boilers will be very big, as like for example, you take our VAT library. Just see the VAT library. Okay, so ground floor, first floor, second floor, and third floor. Let's say 3 floors of it. So the size of boiler will be this much bigger. So think of a boiler that is size of the VAT library with the 3 floor. So that means it is internally inside there will be very hot. Okay. Now if someone go inside the boiler and check for some malfunctioning, so there is a manhole in the top. In boilers usually there is a manhole. A man can enter inside. So once a man enter inside, they go down and then they check for any malfunctioning in the boiler. Okay. So only then he can able to do that. For checking that malfunctioning, you have to stop the boiler, or generally we have to shut down the boiler. Shutting down is a process, will take more than a week. To shut down a boiler, it takes more than a week to clean, to just go inside. So for shutting down a plant, it takes more manual intervention, and human in the loop should be there, and it's a very great process. So if let's say in IT industry, we have deadline, we have a delivery deadline. That means today, day after tomorrow is a delivery. That means from last 1 week they were working like anything. So like full night they will be doing, because the delivery schedule is day after tomorrow. So but shutdown, if a plant shutdown is there, those engineers will never return home even for a week. Even for a week, they have a very tight schedule for the next 1 week to shut down the plant. They cannot simply put power off the button and shut down it. They cannot do that. It takes a week time to shut down a full boiler like this. Just think of the size of the boiler. It's the size of the boiler is almost as big as the size of our library. Ground floor, first floor, and second floor, and third floor. So that is a bigger boiler. Okay. So this is what the manufacturing industries do, and they produce so many materials that what we need. Okay. So these are the operations. So some of the use cases of IIoT. So I have 5 minutes time. Okay. So one thing is healthcare. So healthcare, see that this guy have wore a watch, and this girl also had a watch, and there is a stress sensor. Stress sensor. It identifies the sensing issues in the joints. So usually in the joints, this sensor is used, and it will tell you the stress or the strain what you have in your joints. So that will be counted there. So not only the food, you can place here are these joints. So at any joints you can place this sensor, and you can able to find out the stress of it. So usually sportsmen usually do that. Usually even in cricket also you might have seen Muttiah Muralidharan. So whether you know it or not, so he's one of the leg spinner. So initial days, so usually he just to throw the ball something like this. So people initially thought that he's throwing the ball, not bowling. So then some scientists they just deploy sensors over all his wrist in all degrees of freedom. In robot they call degrees of freedom. So this is 1 degree of freedom, and this is another degree of freedom. This is another degree of freedom, and this is another degree of freedom. Like that for degree. So they deploy sensors across all from shoulders or the joints everywhere, and then they find his action. So that's how the way Mutia Muralidharan claimed that he's a bowler, not a thrower, throwing the ball. Okay, because he just got so more wickets. So that's why he have done. So usually sportsmen do this kind of thing, but healthcare, it's almost a reality because we are experiencing every day. We have watched so many of our faculty members have watched, so many of our students have wearing watches. They count the number of steps every day they walk, and even sometimes for birthdays, your parent might have gifted you a watch or a band, smart band. So you call. So maybe many things you might have experienced now. It become a reality now. It's no longer a dream. It's a reality. Healthcare. Next one is smart home. So smart home again, it's a reality now. So smart home is if you have money, then you can deploy a camera outside your home, outside your flats, outside your apartments, outside your house. So anywhere you can deploy a camera with the storage of 1 week storage. So last 1 week, what happened? You can able to find it out. So that way you can deploy a camera as well. Then you can deploy a smart switch, a smart plug. Okay. So one, two, three, four, five. So a smart plug which is Wi-Fi enabled, which is Wi-Fi enabled. So what happens is whenever you plug it using voice command, you can able to activate the TV. So let's say you want to switch on the TV, you can give a voice command, and if you want to switch off, you can use a voice command. So anything, whatever you connect to through the smart plug, you can switch on or off. Even you are getting a bulbs also nowadays coming with voice command. So in that case, it's almost become a reality now. So even for 1,000 rupees, you will get so many equipments or so many devices within 1,000 rupees. So you can easily get it. Here in the smart home intrusion detection, thermostat. So thermostat is not common in India because in India, in most of the parts of the India, almost 80% of the parts of India, you can live with a normal temperature. So without any extra clothing, you can live almost around the year. So at least in Tamil Nadu, in southern states, you can live almost the round the year 12 months without any wearing extra, I mean a sweater or a extra jerkin or something like that. Without that, you can able to live. Okay, so that kind of climate is prevalent now. Maybe 10 and 15 years ago when you are in Bangalore, so early morning the temperature will be 1-2 degree like that. But even then, now also now it's changing now. But maybe northern parts, they are beyond the Tropic of Cancer, so their temperature is slightly different. So go to highest extreme and lowest extreme, they will go because they are away from the other side of the Tropic of Cancer. So those who are below the Tropic of Cancer, they have a different thing. So in that case, you need to have additional dress materials for 3-4 months. Okay, so that's how the way the smart home. So thermostat is needed for those locations. So during summer, you need air conditioning. During winter, you need air cool. I mean heaters. So that way you need to have that. And smart lighting. So once people are there inside, you switch on the lights and you change the ambience of light. Also, you can change the color of the light according to the mood. Then smart appliances. So and smoke fire detection. So smoke fire detection. So we never use smoke fire detection, particularly in our country, but mainly in the UK and European countries, Americans, they use smoke fire detection because they always use a heater. So during winter, they're prone to heat. So that time they use the fire detection and smoke detection. So they use. So again, it becoming smart nowadays. So smart homes also a reality. Okay, I think it's 5:35. So I'll just stop it here. Any queries, students? Any queries? Any doubts? We'll continue the rest of the thing in next class tomorrow. Any queries?